laser. Someone recall the characteristics of laser. Balakrishna there. The characteristics of laser. 4 characteristics are there. Say one by one. Cynthia.
Yes, sir.
One by one, say the points now. Characteristics.
They are unidirectional, monochromatic,
Okay.
coherent,
Unidirectional or highly directional, monochromatic. Then coherent. So there is a high degree of coherence, highly monochromatic. What's the last point? Yes, a high intensity. Okay. So you have to add high everywhere. Highly directional, highly monochromatic, highly coherent, and yes, high intensity. Right. Then we have studied 3 processes involved in the production of laser. Involved in the production of laser. So what are the processes involved? Vishnu? One of you say the answer. Processes involved in the production of laser. Kumar, say the answer. Umang, are you there? Can you hear me? Say the processes involved in the production of laser. How many processes are there?
4. Absorption, spontaneous.
4. First one is
absorption.
Okay, it is nothing but
Stimulation.
stimulated absorption.
Spontaneous and population.
Okay, so absorption, it is followed by spontaneous
Emission.
And the last one is stimulated emission.
And sir, population also.
What else?
Population inversion.
Population inversion. Okay, so population inversion, after achieving the population inversion only, the stimulated emission process will take place. So it is, you can say these 3 processes. Okay. So population inversion, condition for population inversion. Leo, what is the condition for population inversion? Leo, Jeffrey, I think. Are you there? The Niveta say the condition for population inversion. Bala Vishnu, are you there? Bala Vishnu. Okay, so the condition for population inversion, it is N2 greater than N1. That means the number of atoms in the excited state that must be greater than the number of atoms in the lower energy state. So you can say excited state or in the higher energy state. So the number of atoms in the higher energy state that must be greater than the number of atoms in the lower energy state. So how to achieve this population inversion? So the process the process which is involved to achieve this population inversion, and that is called as pumping. And we have studied different pumping methods like optical pumping, then electric discharge, inelastic atom-atom collision, and direct conversion. So the optical pumping it is happened in the solid state laser, like Ruby and NDR laser. Electric discharge, this happen in the gas laser, and inelastic atom-atom collision, that also takes place in the gas laser. And the last one is direct conversion. It will happen in diode laser, or you can say the semiconductor laser. So these things we have studied in the last class. And one more thing, there is optical resonator and the active material, everything we have studied in the last class. Okay, so Einstein's theory of radiation. It's a derivation, so please take down the notes, then only it will be easy for you and you will be familiar with the derivation. So Einstein's theory of radiation. And here we are going to find the Einstein A and B coefficients. Okay, so we are getting a Einstein theory of radiation and separating Einstein A and B coefficients. So you know as per the energy of atoms can have different energy levels. So each atom have occupied different energy levels. So based on the energy of the atoms, you know that electrons can occupy different energy levels based on their energy. So likewise, these atoms, it is arranged in different energy levels, and that distribution is explained by Maxwell and Boltzmann, and that is called as MP statistics. Maxwell, Boltzmann statistics explained about the arrangement of atoms in different energy levels, like this, from lower energy level to higher energy level. So you can name the energy levels as E1, E2, E3, and up to En. So N is equal to 1, 2, 3, etc. up to N. Wait a minute. So the number of atoms present in the energy level E1, that is N1. So it will goes on like this, N1, N2 up to Nn. So Nn. So in general, this Boltzmann statistics is given by n is equal to n naught. So here we can introduce energy level like this, E naught and n naught. So here this we can consider this n naught and E naught. E naught is the ground level energy, that is the lower level energy, and n naught is the number of atoms present in the ground state energy. It is, and it will move up to the higher energy. So Nn, in general, the equation can be written as, just by heart this, Nn is equal to n naught into exponential of minus En by kT. So K, you know, the Boltzmann constant, and T is the absolute temperature. So this is the equation for Maxwell-Boltzmann statistics. The general equation is this one. So just to mention it as equation number 1. Now, if you want to find for N1 is equal to N naught into e power minus E1 by kT, and for N2, there is the number of atoms to higher energy level, so that is equal to N naught into e power minus E2 by kT. So here, this is the lower energy level, the number of atoms to lower energy level, and this is the number of atoms to higher energy level. So if you want to find the ratio between these two, N1 and N2, so for this you can write N1 by N2 is equal to, if you divide this, what will happen? N naught and N naught will get cancelled, then exponential of minus E1 by kT. So it will move towards numerator plus, so minus becomes plus. The exponential of, if you want, I will write one more step. Exponential of, so minus E2 by kT. So you can write exponential of minus E1. So here it is, plus E2 by kT. So that is e power minus E2 minus E1 is common by kT. So what is E2 minus E1? So this E2 minus E1, it is equivalent to the energy of a photon. So you can write e power h nu by kT. So N1 by N2 is equal to exponential of h nu by kT. So keep this in mind. So here this is equation 1, 2, 3, and 4. So make a note of this. So this is just we will use this particular equation while we derive the Einstein A and B coefficients. Okay, so just make a note of this. I think all of you have copied this. Okay, let me move towards the next slide. Okay. So only derivation. So now the processes involved in the laser action. So first process, as you said, that is stimulated absorption. So if people draw this diagram, this is E1 and this is E2 and N1, N2. So we are applying a photon onto the atom in the lower energy state. So after receiving that, so this is before absorption. So after absorption, it will move towards the higher energy state, that is to E2. N1, N. So before absorption, after absorption. Okay. Now the rate of absorption, there is nothing but a stimulated absorption. Absorption is directly proportional to the number of atoms present in the lower energy state, that is N1. Okay, so we can write this R absorption directly proportional to N1. So R absorption is equal to, here, what are the things involved? Here we are using a coefficient. So this is B. The transition is take place from 1, that is energy level 1 to 2. So B 1 2 and N1, and there is a radiation involved in this transition for absorption. So you can mention it as rho. So B12 N1 rho. So this mentioned the B is for stimulated absorption. We are using this B, the coefficient B. The transition is from 1 to 2, so we are mentioning B12 and N1. The number of atoms in the lower energy state is responsible for this absorption. So N1, and the radiation is also involved. The radiation, energy density of this particular radiation. Okay, so that is rho. It is mentioned as rho. So already we have mentioned 4 equations, I think. So this is equation number 5. So this is the first process, and the second one, spontaneous emission. Spontaneous emission. Here, now the atoms are moved towards a higher energy state. All the atoms are present there. Some of the atoms comes down automatically or spontaneously without any stimulation by emitting a photon. Okay, so this is E2 minus E1 is equal to h nu. This is E2, E1. The atom comes down. Which atoms comes down? The atoms with less lifetime. So N2, this is N1. So the spontaneous emission, the atoms have a lifetime with 10 to minus 8 seconds. Right? It is emitting a photon. Now here, the rate of spontaneous emission is directly proportional to the number of atoms present in the hierarchy state, that is N2. Okay, so rate of spontaneous emission directly proportional to N2. So you can simply write it as RSP directly proportional to N2. Here, the rate of spontaneous emission is equal to, here it is spontaneous emission. Spontaneous, in order to mention the spontaneous, we are using a coefficient called as A. And the transition taking place from 2 to 1, so A to 1. And the number of atoms present there, that is N2. So no radiation involved, no stimulation is there. So no need to put this row here. So it is equation number 6. And the tag process, this is 1, 2, and the tag process, simulated emission. Here, the atoms with the less lifetime, that is of 10 power minus 3 seconds. So normally they will say it is a metastable state. Here we discuss with this E2 and the E1. That's enough. E1, this is N2, N1. Now the spontaneously emitted photon is hit on to the atoms present in the excited state, and it comes down. Okay. So before the stimulation, after the stimulation, it comes down. Before, after. So N2, N1. So E1, E2 corresponding to this. Okay. So it emits 2 photons. Okay. H nu, 2 photons. And these 2 in turn collide onto another 2 atoms, and it will come down by emitting 4 photons. Right? So here also this similar kind of equation we are going to write. That is the rate of stimulated emission is directly proportional to, so here also the number of atoms in the hierarchy level is responsible, so we can write it as N2, rate of stimulated emission directly proportional to N2. So RST directly proportional to N2. So here for stimulated emission, we are using this coefficient, that is B. So RST is equal to B, the transition is from 2 to 1, so B to 1, and here the number of atoms is N2, and the radiation is involved here, the external stimulation is there, so we can write it as rho, that is equal to, so this is equation number 7. Right, we mentioned this equation number 7. So these are the 3 processes involved. Now the condition is the rate of stimulated, the rate of emission is equal to the rate of absorption. So that is the condition. Then we can equate. So write down this 3 equations, 5, 6, and 7. Draw the diagrams. I'll give you 1 minute of time. You can Copy this completely. Okay, so rate of absorption is equal to rate of emission. So we have one process for rate of absorption, that is RAB, that is equal to R SP, rate of spontaneous emission plus rate of stimulated emission. Right? Now we can write, you know, the values for rate of absorption and spontaneous and stimulated emission. So here we can write for rate of absorption B12 N1 into rho, that is equal to A21 N2 plus B21 N2 into rho. Okay. Now take this energy density terms on one side. Now A21 N2 is equal to take it. To erase. Okay, so B12 N1 into rho minus B21 N2 rho, that is equal to A21 into N2, right? So here rho, take this rho outside, B12 into N1 minus B21 into N2. So that is equal to A21 N2. Now rho is equal to A21 N2 divided by B12 N1. This is B21 minus B21 N2. Okay. So I think in your book or the notes, I think instead of rho there may be Q. Okay, whatever you can use, no problem. Notation. So this instead of rho there may be Q. So I used rho. You can follow any one of the notation. So here this rho is equal to, now divide by N2 both in the numerator and the denominator. Divide by N2 both in numerator and denominator. So here what happened means A21 N2 by N2, that will get cancelled. So B12 N1 by N2 minus B21. So here also N2 by N2, that will get cancelled. Right? And next step. Here we can mention some equation numbers. So what is the last equation number? Balavishnu, what is the last equation number?
7,
Someone
sir.
say 7, huh? Okay, so mention this as 8. That is the condition for absorption and emission. And here you mention this equation 9. Right. Now rho is equal to A21. Here we are taking this B21 outside. Consider this as a whole, B21 outside. So B21 inside we have B12. So since we take this outside, we have to divide it by B21 and n1 by n2 minus 1. Close the brackets. Now rho is equal to A21 by B21 into B12 by B21. So what is N1 by N2? Avantika, say the value. What is N1 by N2 as per Maxwell-Boltzmann distribution? Are you there, Avantika?
Sir, I can't get you.
Tell me, ma. N1 by N2, what is the value? Exponential of?
Sir, I can't get you, sir. Sir, can you hear me?
Yeah, I'm hearing. So, what is the value for N1 by N2 as per Maxwell-Boltzmann distribution? Did you get my question? N1 by N2 as per Maxwell-Boltzmann statistics. So N1 by N2 as we derived at first, that is e power h nu by kt. Exponential of h nu by kt. Okay, so that's what we have derived at first. It minus 1. Ah. Forty-five. So rho is equal to, okay, so this is the value, so mention it as equation number 10. Now, as per Planck's energy radiation, so he derived an equation based on the black body radiation, so that we will study in the quantum physics later. So just note on the equation. So as per Planck's energy radiation, rho is equal to 8 by h nu cube by c cube into 1 by e power h nu by kt minus 1. This is equation number 11. Now we have to equate these two equations and write on the answer. That is the last step. So right up to this. Now from this you have to find what is the value of A2 by B21. So instead of A2 by B21, what is the value here? And for B12 by B21, what is the value here? That's all. Now compare equating equation 10 and 11. So from this A21 by B21, for that we got the value 8 by h nu cube by c cube. And instead of B12 by B21, there is no value here. So the coefficient of this, that is 1 into e power h nu. So you can write 1 2 by B21 is equal to 1. So B12 is equal to B21. Okay, so B12. So the rate of absorption, stimulated absorption, that is equal to the rate of stimulated emission. And this is the last one. Equation number 12, and this is 13. So these are the Einstein A and B coefficients. Sorry, this is 13. This equation. Equation 12. A21 by B21 is equal to 8 pi h nu cube by c cube, and B12 is equal to B21. So very simple derivation. So something first we have to by heart one equation from MB statistics, that is n is equal to n naught into e power minus en by kt. That is one equation we have to by heart. And then here this Planck's energy radiation. So other things you just understand and then you write down one by one. Then it will be simple. So this B represent the stimulation process. Some energy is applied externally, then you have to use this B. If it is spontaneous, then you can use this A. And the transition you have to mention. It is from 1 to 2, that is from energy level 1 to 2. Then you mention 1, 2. If it is the transition, atomic transition is from higher level to lower level, that is 2 to 1, then mention 2, 1. So other things are just mathematical. If you have any doubt, you can ask. Okay, just in a nutshell, let me explain bilingual now. Okay, இது வந்து மேக்ஸ்வெல் போல்ட்ஸ்மேன் ஸ்டாட்டிஸ்டிக்ஸ். ஆட்டம்ஸ் வந்து பேஸ்ட் ஆன் எனர்ஜி லெவல், அதோட எனர்ஜியை பொறுத்து டிஃப்ரெண்ட் எனர்ஜி லெவலில் நம்ம அரேஞ்ச் பண்ணலாம். ஜென்ரலாக அப்படி அரேஞ்ச் ஆகிருக்காது, பட் கான்செப்டுவலைஸ் பண்ணி நம்ம இது பண்ணுறோம். ஸோ ஆட்டம்ஸ் வித் லோவர் எனர்ஜி லெவல், ஸோ தட் கேன் பி அரேஞ்ச் இன் த லோவர் எனர்ஜி ஸ்டேட், தட் இஸ் கிரவுண்ட் ஸ்டேட் E நாட். நம்பர் ஆஃப் ஆட்டம்ஸ் வந்து N நாட். அப்படியே வந்து மூவ் ஆகி போயிட்டே இருக்கும். ஹையர் எனர்ஜி ஸ்டேட் we are considered as nth state, ஸோ En. இங்கே வந்து நம்பர் ஆஃப் ஆட்டம்ஸ் வந்து n number of atoms into, so Nn. The general equation, as I said, Nn is equal to n naught into e power minus En by kt. So this is from Maxwell-Boltzmann statistics. So it is a big derivation. So we need only this final expression. So Nn is equal to n naught into e power minus En by kt. Now n is equal to 1. Okay, first energy level, then second energy level. We are taking only these two energy levels. The number of atoms in the first energy level N1 and the second energy level N2. We are writing this equation 2 and 3, and we are taking the ratio between N1 and N2, and finally we get e power h nu by kt. அப்புறம் இங்கே பார்த்தீங்கன்னா ஸ்டிமுலேட்டட் அப்சார்ப்ஷன், 3 ப்ராசஸ் இன்வால்வ் ஆகிருக்கு. ஸ்டிமுலேட்டட் அப்சார்ப்ஷன், ஸ்பான்டேனியஸ் எமிஷன் அண்ட் ஸ்டிமுலேட்டட் எமிஷன். Stimulated absorption, stimulationனால தூண்டுதல். Okay, so external ஒரு தூண்டுதல் கொடுக்குறோம், some triggering, we are giving some external stimulation. எது மூலமா கொடுக்குறோம் அப்படின்னா photon. So this is a photon, light photon. So அந்த photon energy வந்து இந்த atom கொடுக்கும்போது, so it absorbs and move towards the higher energy state. This is stimulated absorption. Then equation I think you have understood. The rate of absorption, எவ்வளவு absorption நடக்குது அப்படிங்கிறது எதை பொறுத்தது அப்படின்னா N1, the number of atoms in the lower energy level, அதான் N1. Then second process, spontaneous emission. இப்போ மேலே எல்லாம் போயிடுச்சு, some of the atoms having low lifetime தானாகவே என்ன வரும்னா கீழே வந்துடும் by emitting the photons. ஓகே, ஸோ இது எவ்வளோ அப்சார்ப் பண்ணி மேலே போச்சோ அந்த போட்டானை எமிட் பண்ணிட்டு கீழே வந்துடும். some other atoms have higher lifetime. ஸோ இந்த photons வந்து என்ன ஆகும் அப்படின்னா it will having an impact onto the atoms present in the higher energy state which is having high lifetime. இப்போ இது வந்து கீழே வரும் by emitting 2 photons. Okay, these 2 photons in turn impact have an impact onto another 2 atoms, and it becomes down by emitting 4 photons. 2 becomes 4, 8, 16, it goes on, and finally we will get a high intensity laser beam. இங்கே எழுதுன மாதிரி இந்த ஈக்குவேஷன் எழுதுன மாதிரி ஸ்பான்டேனியஸ் எமிஷனுக்கும் ஸ்டிமுலேட்டட் எமிஷனுக்கும் எழுதணும். இது வந்து ஸ்டிமுலேட்டட் அப்படின்னு அந்த வேர்டு வந்தாலே இங்கே வந்து என்ன யூஸ் பண்ணணும்னா பி. ஓகே, எங்கேருந்து எங்கே டிரான்சிஷன் ஆகுது, ஸோ 1 to 2 மூவ் ஆகுறதுனால 1 to 2. ஸோ இதுக்கு ரெஸ்பான்சிபிளாக இருக்கக்கூடியது N1, ரேடியேஷன் இன்வால்வ்டு, ஸோ ரோ போட்டிருக்கேன். ஸ்பான்டேனியஸ் எமிஷனில் அந்த ரேடியேஷன் இருக்காது, அண்ட் the coefficient is A, transition 2 to 1, and stimulated emission again is 2 to 1. And we are equating this rate of absorption and emission. ரெண்டையும் ஈக்குவேட் பண்ணி எழுதுறோம். that is equation 8. இப்போ ரோ எனர்ஜி டென்சிட்டி இன்வால்வ் ஆகிருக்கக்கூடியதை வந்து தனியாக எடுத்துக்கிறோம் லெஃப்ட் சைட், அண்ட் ரோ இஸ் ரிட்டன் as equation 9. And now we are dividing the numerator and the denominator by N2. So இதில் மட்டும் தான் N1 by N2 term வரும். Here N2 cancel, here also N2 will cancel. Okay, next இங்கே இதில் வந்து A21 by இதில் வந்து B21 அப்படிங்கிற டேர்மை காமனாக வெளியிடுறோம். ஸோ B12 by B21, N1 by N2, and it will become 1. Right. So that is equation 10. Then இது வரைக்கும் ஒரு step. Then we are equating this equation with Planck's energy radiation. This one we got by heart. Then you equate that. Finally, we will get these equations 12 and 13.